All right, let's dive in. Today, we're basically going to become architects of reality itself. We're going to take really simple flat shapes, the kind of things you draw on a piece of paper, and we're going to learn the secret rules for building them up into the three-dimensional world that's all around us. And it starts with a little bit of a riddle.
I mean, it sounds like the start of a bad joke, right? You've got an ancient Egyptian tomb, something from your kitchen pantry, and a massive celestial body. But the answer isn't a punchline, it's geometry. And by the end of this, you're going to see how these incredibly different things are all born from the exact same, really elegant mathematical rules. So our first construction method is probably the most straightforward. We're just going to take flat surfaces, polygons, and see how we can stick them together to make solid shapes. This whole family of shapes has a name, the polyhedra.
So what in the world is a polyhedron? Well, put simply, it's any 3D object you could build using only flat cardboard cutouts, squares, triangles, pentagons, whatever. The key rule, no curves allowed. The flat surfaces, we call those faces. Where they meet are the edges, and the pointy corners are the vertices.
Every great structure has to start with a solid foundation. And for our polyhedra, that foundation is just a simple 2D polygon. So let's grab one of the most basic ones there is, a square. From this single, flat shape, we can build in two really fundamental ways.
Okay, from that one little square, we've got two main moves. Over on the left, we have what I call the stacking method. Imagine just taking that square and lifting it straight up, making a perfect copy of it on top, and then connecting the sides. And boom, you've got yourself a prism, which in this case happens to be a cube. Now on the right, we've got the point method. Instead of lifting the whole thing, we grab all the corners and pull them up until they all meet at a single point. And that gives us a pyramid. See? Same base, but two completely different buildings.
Now here is where things get really, really fascinating. You might think, okay, I can probably create an infinite number of these perfectly regular 3D shapes, but nope. It turns out that in the entire universe, in all of mathematics, there are only 5. Just 5 of these perfect solids.
And here they are, the absolute superstars of the polyhedron world, the Platonic solids. So what makes them so special? It comes down to two simple rules. First, every single face on each one of these shapes is the exact same regular polygon. So all triangles for the tetrahedron, all squares for the cube, and so on. And second, the exact same number of faces meet up at every single corner. These 5 shapes are the true VIPs of geometry.
Okay, so we've mastered building with flat faces. But what about all the curves we see in the world? A ball, a bottle, a lampshade? For that, we need a completely different, way more dynamic technique. So let's move on to our second method, building with a spin.
This method honestly feels a little bit like magic. You start with a flat 2D shape, just like we did before, but then you pick a line, we call it an axis, and you spin that flat shape all the way around it, a full 360 degrees. And as it spins, it traces this path through the air, carving out a perfectly smooth 3-dimensional solid in space. It's less about gluing pieces together and more about creating a form from pure motion.
And the results of this method? Oh, they are absolutely everywhere. If you take a simple rectangle and spin it around one of its edges, you get a cylinder. That's our soup can. Spin a right triangle around one of its straight sides, and it sweeps out the shape of a cone. And to get a perfect sphere, there's our planet. All you need to do is spin a humble semicircle around its straight edge. The big idea here is that every one of these fundamental curved shapes is born from a simple flat parent.
All right, we've built our shapes, we've got our family of prisms and pyramids, our cylinders and our cones. So the next logical step for any good builder is to start measuring their creations. And in 3D space, there are 2 key measurements we really care about.
This really is the simplest way to think about it. Surface area is all about the outside. Just imagine you had to paint the object, or maybe wrap it perfectly in gift paper with no overlaps. The total amount of paper you'd need, that's the surface area. Volume, on the other hand, is an inside measurement. It's how much water you could pour into the object. It's all about how much stuff fits inside.
Let's start with the volume of our stacked shapes, the prisms and the cylinders. The formula is just beautifully intuitive. All you have to do is find the area of the flat shape on the bottom, doesn't matter if it's a square or a circle, and then you just multiply it by how tall the shape is. It's literally just a measure of that base stacked on top of itself.
And now for one of the magical and kind of weird patterns in all of geometry. If you take a pyramid or a cone,
Its volume is precisely 1/3 of the volume of a prism or cylinder that has the same base and the same height. It's not around a third or close to a third. No, it is exactly 1/3 every single time. It's just an incredible and totally consistent relationship in our universe.
So, when you put it all together, this beautiful hidden pattern starts to emerge. For prisms and cylinders, the ones made by stacking, the volume is simply the base area times the height. For their pointy cousins, the pyramids and cones, it's the exact same logic, just cut down to 1/3 of the total. And yeah, the sphere is kind of the odd one out, with its own special formula, but even it fits into this grand, elegant system.
So now you have it, the builder's guide. You know the two main ways we can construct 3D objects, and you know the basic rules for how to measure them. Which brings us all the way back to our first question. But this time, I'm going to turn it on you. Just look around the room you're in right now. Your screen is a prism. Maybe your coffee mug is a cylinder. How many of these fundamental shapes can you spot just hiding there in plain sight?